Hi everyone, welcome back. So, today in this series, we will cover some more advanced topics on networking that we couldn't cover in the first session on the networking. So, previously on my video, if you check that networking, it has all the basics like I was covering, and I told that I'll clearly cover about some more topics, especially on DNS and all. So that we'll look in this video. So let's get started. Okay, so I have generated this PDF from all the information I have gathered. So yeah, section, I just want to show you first what are all the sections we have in this. So if you see here, the section 1 is on multi-home nodes and multiple interfaces, and that is basically if there are multiple nodes and each node is having multiple interfaces. Second section is on the CKA network troubleshooting. We will see the question on what if you will have a issues with the networking, how do you troubleshoot and all. So this section will help for that. And we will see some more concepts like BR bridge net filter and what is it, how is it helpful. Then and further coming, we will be seeing pod to pod connectivity and node routes, host networking. Section 3, overlay networks and direct routing. So Kubernetes services internals deep dive. So basically current services communication, how it occurs, and what is the use of and here comes like DNS flow deep dive. How does it happen, basically the communication, how DNS is working and all. So yeah, and real traffic absence and all these concepts we will cover here. So I think I felt that something like this PDF is helpful to read and explain. So I thought to explain this way. So yeah, coming to section 1, multi-homed nodes and multiple interfaces. Basically this paragraph is explaining such that, let's say your nodes, your cluster will have multiple nodes obviously, and every node will also have some the connections, right? So basically some connections will be to talk to the external world, so to for the traffic which comes from the external world, but some connections should be internally for the communication, right? So yeah, I just asked it for a scenario analogy, just like a kitchen. Like let's say you go to a hotel, and in the hotel, uh, like just an analogy, it's just an analogy. So let's take, like your hotel is like a cluster. You have a hotel, and inside that some cooking and all will be happening in the kitchen, but the customers will be sitting in that hotel place. So there will be two doors, right? One for the customers to enter into that hotel and have the lunch or dinner, anything, and one more door should be there, that is like a back door, from where the kitchen appliances like the vegetables or some any other appliances and all will be coming, and workers who will be taking that to wash and all. So that back door also should be there. So what if this common door is used for both the cooking as well as for the customers? It will be blocking the customers to enter, and it will be not good, right? And even it is blocking the work for the people who are doing the cooking. So for both the things, it is difficult to manage the operations. That's why we will have two different doors. Similarly, for internal operations or communications, like if you create a pod, and or if you create any service or any resource, the IP allocations are like that. Whatever you are doing, that has to happen with one with a different channel, right? Ethernet cables. I explained this in a previous video, like there will be like Ethernet connections from pod to the bridge, and also some connections to the other nodes via the gateway from one node to another and all, right? So all these connections basically, when and also when a cube API server, and also I explained like through the life cycle of a pod, when it has to be created, the particular communication happens to from the cube API server to the HCD, and that cube scheduler also will be watching that HCD, and it basically it creates the pod, and then it has to also communicate back to API server, the kubelet. So all this communication internally which is happening inside the cluster will be happening through some another cable, like other cable, Ethernet cable. I should not call it as Ethernet, but yeah, I can call it like H0 with pairs. So kind of like virtual cable. Okay, so between them the communication should happen in a different virtual cable, and the communication to the external world, if some other request inside service has to happen, that has to happen through a different communication channel. If both has mixed, then that is a problem, right? So who will tell that this communication should happen through this particular channel? That is told by kubelet. Basically the kubelet is like a captain of a ship, right? So it will basically mention in its file location called var lib kubelet config.yaml, and in this particular location, if you go into this is kubelet is a node specific, right? So in that node, if you go into the location of this, it will be mentioning --node -IP. So this particular channel means this particular IP will be for the internal communications, and the different IP will be there, that will be for the external world, kind of. Okay, so it is passed like this, or passed as a system D argument is what is mentioned. That is about the section 1, multi-homed nodes and multiple interfaces. Okay, and let's go to the next section, which is CKA network troubleshooting. Sometimes in the exam we will be seeing like different troubleshootings related to networking, like this networking is not working, or this communication, this pod is not up, it's still in a container creating state, so debug this and all. So then what you have to do, the first step is, I told you already, the IP address allocation to the pods and the Ethernet cables responsibility is taken by CNI plugins, right? So first thing you have to do is you have to identify that CNI plugin. What you can do is, in that particular node, you can check in this location, okay, etc CNI. So yeah, you can note this, like this is for the IP node IP that should be mentioned by the kubelet in the node, that is responsible for the communication inside. So this is like, yeah, you can read an alternate scenario I explained through the hotel, and yeah. Next, coming in this CNI plugin, this is the file where in the last class also we have seen, right? This is the file location for like you will be seeing like flannel conf or calico conf kind of thing. These are like plugins configuration files. Yeah, so yeah, exactly, here it is mentioning. So in this locations it will be there, so you can verify whether that configuration files are present, and if that is present, second thing you can do is like you can check using this command, that is ctl net.ipv4.ip forward, and this has to be set to 1. So why it has to set to 1 and what happens if that is set to 0? So basically let's take your pod which is in the node A is sending request to the pod which is in the node B. So what happens, and there is one more pod, or there is no pod, we don't know. There is one more node C. Basically the request has to go, right? Like this pod is sending request to certain IP address which belongs to let's say pod 3. So with this pod 3's IP, the request is being sent from pod A. So now what happens, for immediately it can't identify, right? So basically first the node A goes to node C and tells that whether this IP is there or not. It will check in the IP tables, and the default behavior of the nodes here is like routers. And what happens if this net.ipv4.ip forward is 0, let's say node C is receiving that particular request, then after checking its IP tables, at the request whatever it is sent, the packet to the node C, that IP is not there here because that pod doesn't belong to this node. So obviously that IP is not there in this translation. So what happens if this forward is 0? It will just drop the packet. Now even though the node A sent the packet for the request, the node which is not the right node received it and then dropped the packet. So this is a problem, right? So that's why your maybe the pod is not getting created or the request is not sent. So that is also one of the problems. That's why this is a method like systems control w, like -w is to write that net.ipv4.ip underscore forward is equal to 1. This way you can set it as 1 if it returns as 0. So yeah, this is one more analogy. And here if you can read, like pod A wants to talk to service VIP, IP table rules cache the packet. Yeah, this I just explained through pod scenario. They're explaining via the services scenario. Okay, so basically when a pod has to send a request, what happens, there will be a service, right? Sometimes it hits the service, and services, we know there will be virtual IP addresses assigned to this service VIP. There is a queue proxy, and what is the work of queue proxy? It works like a middleman, and this queue proxy basically translate this service VIP to the real IP address of the pod. So the translation is done by the queue proxy. Now what happened if this service VIP, whatever it takes, and the real IP of the pod lives in a different node, that packet has to be forwarded, right, out of that particular node to the another node. Now if that is 0, the Linux kernel will tell that the new destination is pod B and realizes like it's not belonging to node, the current node, so it will directly drop the packet and the service routing completely fails. Now this is the problem, like it will be problem for even the pod to pod communication, pod to service communication doesn't help. So that's why this net.ipv4.ip_forward has to be 1. Okay, and then the third thing is br net filter. This is one more important module. I didn't understand this at the first, took me some time and research on this. So basically, if you see my previous class, there were some things I was explaining on let's see, wait. So yeah, here if you see, I think it's not that clear, but I think yeah, I can manage. So I told that these pods and inside one node can communicate using this bridge network, and at 0 are the one end point of the cable, and another end point will be like vth1 vth2 and all connected to the bridge. So what is this bridge? It's like a it is also created using that CNI only. So basically we can denote it like CNI 0 bridge. Coming back, not this. So coming back, now that bridge, whatever it is acting as a layer 2 yeah, layer 2 switch. Okay, now in your previous classes on computer networks, like in engineering, you would have listened about layer 2, layer 3, all those things, right? And inside the layer 2 certain protocols will work, and layer 3 certain others. So basically the switch belongs to layer 2 of the networking, and what happens is the IP tables which are responsible for the translation are belonging to layer 3. Okay, and yeah, layer 3 or layer 4. This module forces traffic. So which module? BR net filter forces the traffic passing across layer 2 bridge to send up to IP tables for inspection and routing. If this module is missing, service virtual IP translation queue proxy silently fails. If BR net filter is not there, the traffic bypasses IP tables completely, it never touches it. So what happens is, you have a bridge or a switch, right? Basically for the translation, which is like a CNI 0 bridge, and that is responsible for communication between the pods and all. Now what happens is, if you don't have BR net filter, whenever a request goes from an pod 0 to the bridge which we are seeing earlier, so it just looks at a certain address. There is basically network address translation, address translations will be there, right? IP tables will be there. So this is one more layer. This is layer 2, this is layer 3 or 4. Now the pod is communicating using the cable to from its endpoint to the bridge or the switch. Now since this is in the layer 2 and BR net filter is not actually set, so what happens is, let's say in the services we know that it uses the virtual IP, right? So this virtual IP has to somehow translate it to the actual IP address of pod. Then only this pod to this pod the communication happens. Because they are using services, we send to that service and that IP address should be translated, and this is done by kube proxy using the IP tables and all. So that we know. So if this BR net filter module is not set, what happens is whatever the request coming to this bridge, it will think that this service virtual IP is not a virtual IP, it's actual IP, and it will try to search for that, let's say 94.0.0. It will try to search for this IP, and it doesn't actually exist. Actually it doesn't exist, right? So, and translation also it didn't happen because of BR net filter. So it doesn't translate or go to the IP tables. So it just searches like since other pods are also communicating to this bridge, so it just searches in that connections, like whether they are there or not. But it is not the I hope you understand, right? Like it is not the real IP address of the pods. It's actually a virtual IP that has to be translated by the kube proxy, and it didn't happen. Now that's why the packet doesn't get moved to the right pod or right address. So it fails. And let me clear this. Okay. Yeah. So, and layer 3, router or firewall, this is where IP table it, okay, that we have seen already. So here you can read about it, that packet hits that CNI bridge and all. Why it fails? It bypasses the IP tables. Basically, the translation never happened, and it thinks that it is going to look for a real IP, but it's actually not physically existing. It's a virtual IP. So the packet gets dropped and the connection times out. So that's what it happens. So what it's actually doing, the bridge network filter, it's like if you enable it, it tells the kernel that I know this packet is traveling across layer 2 bridge, but before let it cross, and you pass it up to layer 3 IP tables to see if any rules can be applied. Like there it is used to pass through the forces that packet to move to the layer 3 and check for the rules if it can be applied, and there it can check that some translation happens, and okay, so we can translate it via this table, and the request can go to actual pod IP of this. So that happens. Okay. And IP tables is a toll booth in the middle of the city without BR filter. Okay, this is some analogy, and you can just read about it. You can pause the video and read about it. Then also we have like enabling BR net filter is like putting a police officer. Yeah, this is also one more analogy. So you can just read an analogy if you need one more example, right? So of course you need a bridge, something over there like BR net filter, which stops and want to bypass it to the layer 3 and make the connection enable. So that is one thing. And then one more thing you can do is debugging pod to pod connectivity. You can go into one pod using kubectl exec -it and that pod name, and you can do an SSH, and inside that you can ping the another pod's IP, and if you are failing to communicate to pod B, exit and check the routing table of the node using IP route command. Then you should be able to see a route the node where to send the traffic for the pod's destination CIDR block. So basically this will be having all the routing details. If you are not able to ping the other pods, then you can this is suggested that you can do IP route. The fifth thing is host networking. So I think I already took this in the last section, that host network is by default false, which makes or which makes the pod to get a separate network namespace and separate network IP, that will be the real IP. And if you make it as true, the IP which the pod gets is exactly same as a node IP. That's what it mentions. And ingress controllers or network monitors tools, it needs to listen to the node ports directly without NAT translation. So I already told you, like in some use cases this will be helpful, but not for all, especially when you need some security kind of things to the pods. And then there is a one more thing is when the network host network is true. Let's say you run as run an Nginx container, and let's say it has the port 80 to access. Since the Nginx container host network is true, it takes the IP of the host network, right? It will have the same as IP as the host network. Let's say you need another pod of the Nginx. Now again you will create an Nginx pod, then you will get a clash because the second Nginx also by default runs on 80 port, and since here also you mentioned as host network true, both uses the same IP, same port, there comes a clash. But by default it is false. That means every pod will get its own. If you make it as true explicitly, this happens, but by default it is false. And if it is false, what happens? Every pod gets a real IP address. So even when pod A is having one IP, even when it runs on port 80 and second pod also runs on port 80, both IP doesn't match, right? So there will be no clash between the pods. So you can run hundreds of Nginx containers with host network as false and hundreds of those pods based on that. I mean, if the resources are eligible like to run on that pod, they can run as many as they want with host network false, because those IPs are different and there will be no clashes between the ports. And we'll see this in section 3 in the next class. Thank you.